What's up, my people? This is the Exam 8 review session. This is totally brand new. I've never done anything like this before, so I'm not really sure how it's going to work. You're kind of the guinea pigs, but we're just going to go for it, okay? So here are the video rules. Number 1, pause, record, fast forward as needed. I'm going to work really quickly through some of these problems, well, actually all the problems on the Exam 8 review items. And there's going to be times where it might go a little too quick for you and you need to pause and just kind of take in what you see. There might be times where you need to go back and kind of rewind and listen to something a second time. Or there might be something that you just move on past because you got it correct and you don't need to hear me explain that question. Rule number 2, make notes of any more questions that you have. You're going to see as we get into this, I don't actually work out every single part of the problem. For example, if I need to do quadratic formula, I don't show the work for that. So if you don't get the same answer using quadratic formula, come and talk to me, and I can show you some of my more detailed notes for these problems, and we can kind of compare and contrast what you have to what I have. And y'all, rule number 3 is probably the most important. No voice jokes about my voice, and no jokes about my fat fingers. Okay, please, I'm very sensitive about my fat fingers. You're going to see them a lot. Please don't make fun of them. Okay, my fingers are people too, and I'm sensitive. That word says sensitive. And lastly, I want you to enjoy this. I hope that this is a cool thing that we can keep doing in the future. Okay, all right, so here we go. We're going to jump right into problem number 1. Okay. Here we go. Let me make sure that this is set up perfectly here. All right, here we go. So problem number 1. Okay, and you'll see one thing that's kind of nice about this is the top left-hand corner. You can actually see the number of the problem that I'm working on. So if you need to fast forward to the problems that are important to you, that's totally fine. Just look for the number in the top left-hand corner. Here we go. So this problem, the directions for these first, 10 questions are the same. Factor completely, number 1, and number 2, find all the zeros. So the first thing that I look at is the function that's given to me here. Has 1, 2, 3, 4, 5 terms. If there's an odd termed polynomial, it's probably a signal to you that it's not going to be able to be factored by grouping. So I took grouping off the table and I didn't even try it. What I did is I actually graphed it on the graphing calculator. And this step right here is actually probably going to be what takes you the longest time on the test. It took me a little bit of time to adjust my viewing window on the calculator to be able to see a good picture of this graph. There's a lot of different windows that'll work for that. If adjusting your viewing window is something that's confusing to you, that's a really easy thing that we can talk about in tutorials. If you come in, we can go through any one of these questions and I can help you figure out what a good viewing window would be. Okay, so here we go. So what I did is I graphed this, and then I see visually that there's 1, 2, 3, 4 zeros to this function. And what I did next is I looked at the calculator using the table function, and I saw that this 0 is -4, this one's -2, and this one over here is 6. Okay, so then I got 3 zeros that I know for a factor of zeros, and what I actually did is I used the original function and I did synthetic division 3 different times. Once, twice, 3 times, using the 3 different zeros that I got from the table. And when I was done with that, what I had left over was 3x minus 1. So then, since I look and see that 3x minus 1 is linear, I'm allowed to, I know that I'm done with the factoring. So for part 1 of this question, when I factor it completely, I took each one of these zeros, for example, x equals -4, and if I translate x equals -4 to a 0, that would translate to x plus 4. The x equals -2 would translate to x plus 2. The x equals 6 would translate to x minus 6. And then I had the piece 3x minus 1 that I had left over after I did all my synthetic division. Okay, so then what I do is you set each one of those equal to 0, and you solve. We've got x equals -4, x equals -2, x equals 6, and x equals 1/3. Y'all, before I move on, I probably should have showed you this before I even got into question number 1. And some of you that are skipping question 1 will never even actually see this, but I have to take a second and show you the genius contraption that I built. So the video, those are my son's Legos. So I built a little tripod for my camera to sit on so that I don't have to hold it and I can use both hands. This is like one of my most proud moments. I am so proud of myself for this. and I just had to show it off. So my time to kind of gloat and brag about how awesome I am is over. So let me get this set back up, and we'll get back into some more problems. Okay, so let me get it just right. There we go. Okay, so that's essentially question number 1. Question number 2 is very similar to question number 1. Same direction, same concept here. The difference here is that I have just a different function. So it's 1, 2, 3, 4, 5 terms. So grouping, I'm going to take grouping off the table. Again, first step was to draw the graph on the calculator. And what I was able to identify from the calculator is that there are 3 zeros, -3, -1, and +3. Now the nice thing about this is the fact that I am able to identify all 3 of the real zeros from the table. I don't necessarily have to do any synthetic division. Okay? But what I realized here is this is a 4th degree polynomial. And a 4th degree polynomial has to have 4 roots. I only found 3. 1, 2, 3. So what we actually have to do is I did some division here, some synthetic division with the zeros I found from the table to figure out that what I have left over is x plus 1. So actually when you take these zeros that you found in the calculator and translate them into factored form, what you see here is you have x plus 3 times x plus 1 squared times x minus 3. The x plus 1 actually occurs twice. Now some of you probably remember what we talked about in class, and you could visually tell that x plus 1 was going to happen twice. What we talked about in class is that when the function bounces off the x-axis at one of the zeros, when it bounces off of the x-axis at one of the zeros, that actual zero has what's called a multiplicity of 2, meaning it's going to happen 2 times. Hence the need for the x plus 1 squared. Okay, so then all you have to do is take each one of these factors and set them equal to 0, and we get x equals -3, x equals +3, and x equals -1. So that's example number 2. All right, example number 3. Okay, example number 3. Again, we have a 1, 2, 3, 4 term polynomial. Okay, so since it's an even number of terms, I did kind of mentally try to factor this by grouping, but I can tell pretty quickly that 2 and 17 and 20 and -96, I'm not going to have a way to actually get those to be for grouping to work. So again, I resorted to the calculator and I got a decent sketch of the graph, and I see that there's actually only one real zero to this function. It's x equals 8. So then what I was able to do is I used x equals 8 to divide synthetically the original function, and I got a quadratic trinomial left over. I got 2x squared minus x plus 12. And then what I did is I used my little tic-tac-toe method, okay, to try to see if I could factor that trinomial. And actually it worked out so that I could not factor it. It's impossible to factor. So then what I did is I know that I'm ready to go ahead and write it out in factored form. So this one was actually pretty easy in factored form. It's simply x minus 8 and 2x squared minus x plus 12. Again, you can leave this as a trinomial because you already checked to see if it could be factored. If you could factor it, you need to factor the trinomial. But again, this trinomial does not factor, so you are A-OK to leave it as is. So then what I do is I set each one of these factors equal to 0 and solve. X minus 8 equal to 0 is easy. That's x equals 8. And then I used quadratic formula here. I didn't show the quadratic formula, but you could do that on your own. And if you do it correctly, what you should get is, when you simplify everything, x equals 1 plus or minus I root 95 over 4. All right, moving on. Number 4. Okay, number 4. Now, number 4, let me try to get all this to fit on there. Perfect. Okay, number 4 was a little bit unique. There are a couple interesting things that happen here. Again, not a candidate for grouping. It has too many terms. And what I looked at here is I drew a sketch of my graph on the calculator, and I identified 3 real zeros. In fact, all the 3 real zeros that work here. Okay, and I have -3, -2.5, and 0. Now here's why I knew that I needed to still do some synthetic division. This is actually a 5th degree polynomial, but there's only 3 real zeros. So since it's a 5th degree polynomial and I visually see that there are 3 real zeros, and it doesn't look like any of these zeros have a multiplicity of 2, that tells me that there are still 2 imaginary roots that I need to find. So what I did here is I went through and I used -3 and -2.5 and did synthetic division 2 different times. And I got a trinomial left over. I got 2x squared minus 6x plus 20 left over. Well, then I factored out a 2 just to clean it up a little bit, and I had x squared minus 3x plus 10. So then I thought, are there two numbers that multiply to give me 10 that add up to give me -3? You might immediately kind of think of -5 times 2. Well, that would add up to -3, but it doesn't multiply to +10. So it's impossible for this question to factor. It doesn't factor. So then what I would do is if I write it out in factored form, I use that x equals 0. The way that I translate that as a factor is that's just a standalone single x. Okay, so whenever you have a 0 that is literally 0, the way that you'd write that out is just a standalone x. That's important to note. The other two, the x plus 3 and the x plus 2.5, I hope at this point you're able to follow that. And then I had the x squared minus 3x plus 10. Uh-oh, Mr. Kozad forgot something. Remember how we factored out this 2 at the beginning? After I got this trinomial, I still need a 2 in my factored form. So I'm going to go ahead and add a 2 there so that it's perfect now. I wish I could tell you that I only forgot the 2 to see if you were paying attention, but it was my mistake. Remember, I make a mistake about once every 10 years, so that was my one mistake. So then what we do from factored form to get all the zeros, we just take each factor and set it equal to 0. 2x equals 0 gives me 0, -3, -2.5. And for this trinomial here, I just use quadratic formula. Again, I didn't show the work for that. Come ask me if you need to see that work. But if you did it right, you should get 3 plus or minus I root 31 over 2. Okay, so again, big issue on this one is kind of knowing how to handle a 0 that is just x equals 0, and then doing synthetic division with a decimal. Okay, but that's question number 4. All right, here we go. Question number 5. These questions take a little bit less space and are a little bit more straightforward. Okay. So question number 5 is the first thing that you should notice here about question number 5 is it is a quadratic form trinomial. It's not a quadratic equation, but it's in quadratic form, meaning this exponent 2 is half of 4. So we can actually try to factor this just like normal. And if you do your handy-dandy tic-tac-toe method, you'll see pretty easily that this does factor to 2x squared minus 3 times 4x squared plus 9. I would imagine one of the biggest mistakes that people make here is they would just write 2x minus 3 and 4x plus 9. They would forget to make sure that each one of these needs to be squared. Okay, so that's the difference. When you're in quadratic form, you need to take this exponent and divide it by 2, and that's the degree that you use on your binomials here. And then to get the second part, all you do is you take each one of the factors and set them equal to 0. So if you do that correctly, you get x equals plus or minus 3 over 2, and x equals plus or minus 3i over 2. Now some of you are super cool, and you want to actually know how to simplify these radicals. So let me go through that really quickly. On the test, I will accept this as original credit, or full credit, I should say. You don't have to continue it further, but some of you are just overachievers, and you truly are wolves, and you want to know exactly how to get this beautifully correct. So the way that I would do that is I would actually multiply. It's still plus or minus, but I'd think about it as the square root of 3 over the square root of 2. And then I would multiply the numerator by the square root of 2 and the denominator by the square root of 2. So what actually ends up happening there is that I get x equals plus or minus the square root. I can actually combine those two into 3 times 2 is 6, all over the square root of 2 times the square root of 2 just becomes 2. So the absolutely perfect answer, if you want to get super awesome points, is x equals plus or minus root 6 over 2. But again, if you on your test for this go around leave it as plus or minus root 3 over 2, you'd be fine with that. Question number 5 in the books. Hope you're having fun. This is so awesome. I'm doing this actually in my kitchen, so it's more comfortable here than in my empty classroom because I talk to myself a lot in my kitchen. So at any rate, number 6 is actually almost identical to number 5. It's a quadratic form trinomial that you're going to factor using your tic-tac-toe method. Pause it here if you need to compare and contrast what you had with what I had. But it factors pretty easily to 2x squared plus 5 times x squared minus 9. Make sure, again, just like on the last problem, make sure you're using x squared here and here and not just x. It's a big mistake. And then I hope that that siren in your brain is going off right now, that x squared minus 9 is, of course, difference of squares. So we factor that to x plus 3 times x minus 3. So this is what I need to see for you to get full credit on factoring completely. And then obviously we take each one of those factors, set them equal to 0, and solve. Pause it there, make sure you got those correct. Those are pretty self-explanatory. Number 7. Okay, number 7 is a little deceptive. Okay, this is a trinomial, but ask yourself this question: is it in quadratic form? Go ahead and answer yes or no. Is it in quadratic form? You're right. If you said it's not in quadratic form, you're perfect. Okay, this exponent in here is a 1. And that's not half of 3. Okay, so this is not a quadratic form that you can factor. So that's why I resorted to the graph on the graphing calculator. Again, just make sure you get your window correct. Okay, and then what I was able to find is actually only one of these 3 zeros were convenient to use. This one right here is 1. So then what I did is I took the original function, okay, and I divided with synthetic division. Now some of you who did this that got the wrong answer, you probably forgot to use the spacer 0. Remember, if you look at the original polynomial, you have an x squared term that's missing. So you have to use a spacer 0 here to be able to, for the synthetic division to work out correctly. So then after we do that, we get this trinomial. We get 4x squared plus 4x minus 16. Okay. Then if I factor out, the greatest common factor here is a 4, so I pull out a 4. I get 4 times x squared plus x minus 4. It wouldn't take you long to quickly realize that that cannot be factored. Okay, you can't find two numbers that multiply to give you -4 and add up to give you 1. So what we have to do is obviously write it out in factored form, which is nice. Don't forget that 4 that you pulled out originally from here. Make sure that that's still included. Times the x minus 1 times the trinomial that you had, x squared plus x minus 4. So then we take each one of those and we set them equal to 0. Okay, 4 will never equal 0, so that kind of goes away. But the zeros for this function are x equals 1 and x equals -1 plus or minus the square root of 17 all over 2. Again, I got this expression here, or this set of zeros here, from using quadratic formula. Not shown, but you should be able to do quadratic formula and get that correct. If not, come in and talk to me about that. That's number 7. Okay, moving on, number 8. Okay, number 8 was interesting. Okay, number 8 was another problem where if you actually looked at the graph, you can find a couple of the zeros. But one of the things that I'm hoping you start to notice, some of you are really going to start to figure this out, is the 0 at 1 bounces off the x-axis. So you already know that that 0 is going to occur 2 times. And you actually need to know that in order to do this problem. So if you ignored the fact that since the curve bounces off that 0, that means that there's a multiplicity of 2. If you ignored that, you would have stopped right here. Okay, you would not have this part. So what you would have done is synthetic division 2 times, and you would have been stuck with an expression here that you could not factor by grouping. Okay, so that you'd be stuck at that point. The only way to actually solve this completely is to know that you have to divide by 1 a second time. Again, I know that it's a second time because as you look at this graph, the graph bounces off of that 0, which means it has to happen 2 times. So that's why I divided 2 separate times. Well, when you divide by that separate second time, you actually get a trinomial x squared minus 2x plus 3 left over. That's pretty simple looking, but it can't be factored. Okay, it can't be factored. So when you get to something, a quadratic that can't be factored, you know that you have it factored completely. So if we write out our factors, the x plus 2, and look here, the x minus 1 squared times x squared minus 2x plus 3. Okay, then we set each one of those equal to 0, and the rest is pretty simple. We get x equals -2, x equals 1, and then if you did quadratic formula correctly, you'd get 1 plus or minus I root 2. Okay, some of you may have got something a little different here. Just remember, if this number, the original number, and the denominator are all divisible by 2, you need to factor out. So if you left it as 2 plus or minus 2I root 2 all over 2, remember to divide this number, the number in front of the radical, and the denominator if you can. Okay? That is question number 8. Question number 9. Hitting this fine? Y'all, I'm having fun with this. We really need to do this more often. Okay, I'm sorry, this one's a little tight to see all of it. Okay, question number 9 was a doozy. I'm going to go ahead and tell you now that I think question 9 was the hardest question on the review sheet. Naturally, I thought it was the most fun, so I'm the most excited about this one. So here we go. Number 9 was kind of me to give you this hint that one of the zeros is 4 plus 2i. That was very kind because you don't have the skill set to be able to do this problem without that hint. Okay, you just wouldn't be able to. It would be just brutally uncomfortable to ask you to do that. So here's what I know. Here's how I use the hint. Okay, if 4 plus 2i is a 0, then we can take that 0, and I don't know if you can pick up on this on the screen here, but if x equals 4 plus 2i is a 0, that means 4 plus or minus 2i needs to be a 0. Remember, that's called the complex conjugate theorem. The complex conjugate theorem tells us you're never just going to have the positive without also having the negative. So what that means is I can write this as x equals 4 plus or minus 2i. Again, I was only told that 4 plus 2i was a 0, but I'm smart enough to remember the complex conjugate theorem, which tells me that I can actually translate that to 4 plus or minus 2i. So then we go through and we actually find this factor. So I subtract 4 on both sides, and then I rewrite 2i as the square root of negative 4, and to get rid of the plus or minus and the radical, I square both sides. So when I square both sides, I have x minus 4 squared equals negative 4. Well, if you clean all that up and get it all simplified, moved over to the same side, you'll end up getting x squared minus 8x plus 20. And this is where this problem really gets fun. Okay, this is where number 9 really gets fun. So then I know that this is a factor, so I know that if I divide this into the original function, I should get a remainder of 0. The problem is you can't actually use synthetic division here because you can only use synthetic division, if you remember, when you're dividing by a linear binomial. Well, x squared minus 8x plus 20, that's not a linear binomial. That's a trinomial, so you have to do the long division. Some of you may have not known what to do that. So this would be a good point to pause and try the long division on your own if you didn't do it, and then come back and check to see if you got the same thing that I did. If you did the long division correctly, you should have had x cubed minus 5x squared plus 0x plus 18. Okay, so that's where we're at with this. So the next thing that I looked at is when I actually drew the graph on the calculator, I was able to deduce one of the 3 zeros is actually 3. So then what I have is I've already factored out x squared minus 8x plus 20. So I had x cubed minus 5x squared plus 0x plus 18 left over. So now what I'm going to do is now I'm going to go back to synthetic division and just use what I have left over from my long division. Okay, so now I can use synthetic division here using the 3, and then I can break this down to a quadratic trinomial to x squared minus 2x minus 6. Which doesn't take you long to figure out that it cannot be factored. Okay, so here's where we're at. We have x minus 3 times x squared minus 8x plus 20 times x squared minus 2x minus 6. I can already tell you that there are a few of you that need to pause it right now and go back to the beginning of question 9 and watch this whole little section again, because this is probably the hardest question on the page. It requires a lot of thought and a lot of connections. Some of you missed some of the things that we went through, and you need to go through and talk through them or watch them again. Okay, so here we go. Second part is to find all the zeros. Simply take each one of these factors and set it equal to 0. First one's easy, x equals 3. Quadratic formula will give you 4 plus or minus 2i if you do it correctly. And then quadratic formula will give you 1 plus or minus square root of 7 if you do it correctly. Again, didn't show the quadratic formula, but I promise that's what you get when you do it. So try it on your own. If you get something different, come in and talk to me about that, and we'll try to find your mistake. Okay? All right, let's move on. Number 10. Okay, number 10. Here we go with number 10. All right, number 10 is a function, and you're given another hint. You're given that x plus 2 is a factor. So I didn't even start with the graph yet. I started with the division. So I took the original function, and I did synthetic division using -2. And here's what I got. I got a very interesting byproduct after the division. I had x to the fourth plus x squared minus 30. Okay, x to the fourth plus x squared minus 30. Now this should trigger an alarm in your brain that this is in quadratic form. The middle degree is half of the lead degree. So what I tried to do is I tried to factor this. Thought of two numbers that multiplied negative 30 that added up to 1, and pretty quickly I got 6 and negative 5. So when I factored that, it factored to x squared minus 5 times x squared plus 6. Now neither of these, I don't know any tricks on either of these to be able to factor them further, so I was able to go ahead and jump right down to writing it completely factored. X plus 2, I got that from the hint, and then x squared minus 5 times x squared plus 6 I got from doing the synthetic division and then factoring my trinomial at the end. Then all you have to do to finish is set each one of these three factors equal to 0, and you get negative 2 plus or minus root 5 plus or minus I root 6. Okay, that's question number 10. Okay, for the next set of questions, the last 4 questions that we have here, we actually have different directions. These are the questions where you're actually given some zeros and asked to write a polynomial function with integer coefficients that has the given zeros. Guys, integer coefficients just means when you're done, when you write out your answer, there should be no fractions, no decimals. It is okay to have positive and negative numbers, those are integers, but no fractions, no decimals. Okay, so here we go. The fact that we're given that there's 3 zeros that we're given, 2i, negative 3, and 4. Well, with the 2i, remember what we talked about earlier with the complex conjugate theorem, you know that if 2i is a solution, negative 2i must also be a solution. So if I work backwards from just that 0, I can rewrite that as x equals plus or minus 2i, and then I can rewrite it as x equals plus or minus square root of negative 4. Then to get rid of the plus or minus in the radical, I square both sides, so I have x squared equals negative 4. Then move the 4 to the left-hand side, so I have x squared plus 4 equals 0. Once you get everything equal to 0, you can stop. That's the factor, x squared plus 4. X equals negative 3 and x equals 4. Those are pretty easy to write as factors. So now I actually have 3 factors. I've got x squared plus 4 times x plus 3 times x minus 4 equals 0. Well, all I have to do next is I have to actually multiply this. And what I did is I did x plus 3 times x minus 4 first to get x squared minus x minus 12. And then I took that trinomial and multiplied that by x squared plus 4. Now, I didn't show all the work to get that. I think that you can do that. You should be able to do that. If you do it correctly, this is what you should get. X to the 4th minus x cubed minus 8x squared minus 4x minus 48. Again, if you did it correctly, that's what you should have. Okay? All right, moving on. Number 12. We're almost done, y'all. This is fun. Number 12. Okay, again, 3 zeros given. 2/3, negative root 3, negative 1. The 2/3, let's go through that one really quickly. Okay, so the 2/3, I could think of 3x equals 2. Multiply both sides by 3, and you get 3x equals 2. And then subtract the 2 on both sides, and we pretty quickly get 3x minus 2 equals 0. Remember, when you get it equal to 0, you're good. You can move on to the next one. Now here's the real twist and turn in this question. There's also something called the irrational root theorem, which means if you've got an irrational number, which in this case is a radical, okay, if you've got a radical, you're never just going to have one radical answer. You're going to have 2 radicals that are zeros, the positive and the negative. So that's why I think of this as x equals plus or minus the square root of 3. So to get rid of the plus or minus in the radical, I square both sides. So I get x squared equals 3, and then I subtract the 3 to the left, and I get x squared minus 3 equals 0. Since it equals 0, that's the factor. X equals negative 1, that's easy. That translates to x plus 1 equals 0. So then I take my 3 factors here, and I'm going to multiply all 3. Now what I did when I multiplied this, you could do it differently and still get the right answer, but what I did is I did 3x minus 2 times x plus 1. I went a little out of order. I did 3x minus 2 times x plus 1, and I got 3x squared plus x minus 2, and then I multiplied that trinomial by x squared minus 3. Again, I didn't show that work. You should be able to handle that. If you do it correctly, you should get 3x to the 4th plus x to the 3rd minus 11x squared minus 3x plus 6. All right, 2 more questions, and then we're done. Number 13. Okay, number 13 gives me 1, 2, 3 zeros. Now, hey, Before, this is only 3 zeros. A lot of you on that quiz, oh my gosh, a lot of you on that quiz added a little comma after the 4. You thought, oh, Kozad and Wallace must have just forgot the comma. So you added a comma and you broke that down to 0, 4, 3i, and -2. That's not the case. I promise you, we have proofread this test multiple times, and if there is no comma, there's not supposed to be a comma. So here we go. We're going to take these 3 zeros and think about them separately. X equals 0, that's actually really an easy one to deal with. We'll come back to that later. The real meat and potatoes on this question is how you handle x equals 4 plus 3i. Again, anything that has an I in it, you have to remember the complex conjugate theorem, which tells you that you're never just going to have the positive without the negative also. So we can think about this as x equals 4 plus or minus 3i. So then if I go through the process of working backwards, I subtract 4 on both sides. I rewrite 3i as the square root of -9. To get rid of the plus or minus in the radical, I square both sides. So I have x minus 4 squared equals -9. And then I square that binomial, and I get x squared minus 8x plus 16 equals -9. And then add 9 to both sides, so we get x squared minus 8x plus 25 equals 0. Man, after doing all that, x equals -2 is so easy. You just add 2 to both sides, you get x plus 2. So now there you go. You got 3 factors. You've got x times x squared minus 8x plus 25 times x plus 2. So the way that I did this is I actually multiplied the trinomial times the binomial first, and then multiplied everything by x afterwards. So I had x to the 4th minus 6x cubed plus 9x squared plus 50x. Again, there's a lot of that multiplication that I did not show, but you can do that on your own and check your work with what I have. Okay. Last but not least, question number 14. Sadly, our time is about to end. But the great thing about videos is if you want some more, you can just go back and watch it all over again. So here are, there's actually 2 zeros given. We're given both a radical and a complex 0 with an I in it. So this is an application of both of those theorems that we know. The irrational root theorem tells us you're never going to have just one square root. It's always going to be the plus or minus. So if I think about this as x equals plus or minus the square root of 7, to get rid of the plus or minus and the radical, I square both sides. So I get x squared equals 7. Subtract 7 on both sides, and pretty easily you get x squared minus 7 equals 0. Now the second root, you have 2, and we rewrite it as plus or minus I root 2. Even though it wasn't given as plus or minus, we know the complex conjugate theorem tells us that 2 plus or minus I root 2 are both zeros. So then just like problem number 13, we're going to work backwards here, okay? And we subtract the 2. Then we think about it as we square both sides. The I goes back in the radicals a -1, and then we square both sides. And we get x minus 2 squared equals -2. X minus 2 squared gives me x squared minus 4x plus 4 equals -2. Add the 2 to both sides, and we get that trinomial to be x squared minus 4x plus 6. So here, these are actually our only 2 factors. Okay, this one here, x squared minus 7, and x squared minus 4x plus 6. Those are my only 2 factors. So those are the only 2 things that I have to multiply here. Oh, man. This is not... did I do that wrong? What did I do wrong here? Yeah, I think I did something wrong. No, I didn't do something wrong. That's good. At any rate, sorry. It's late at night, and I'm losing my mind here. So we should have x to the 4th minus 4x to the 3rd plus x squared plus 28x minus 56. I feel like I might have done something wrong here, but y'all are smarter than me. So you can figure out if I did something wrong here. I don't want to have to redo this entire video right in the last minute. So check that for me. And if I did make a mistake, I know that you'll all probably tell me about it because you love when I make mistakes. But there it is, folks. That's all 14 review items to the best of my ability. We did awesome until the end. I'm paranoid and panicked now that I have a mistake right here at the end somewhere. But check that for me. We'll talk about that some more. Please go back and rewatch any of this that you need, and do not hesitate to send me remind messages or come in and see me before school if you need any extra help with anything that you still didn't understand in this review. All right, my people. Kozad signing off.